Hey guys, this is a video for reintroducing exponents to you. You would have seen exponents in your grade 9, grade 10, perhaps even in grade 11. So let's start. Exponents really are a shortcut for writing something like this. So x times x times x, you can think of this as x to the power of 3. So this is just another way, a shortcut way of writing that. What if we have to write -1, -1? You can write this as -1 to the power of 2. So there are three of the same multiplying, it is to the power of 3. Two of the same multiplying to the power of 2. You get the idea. If I have to multiply something like this 5 times, a is multiplied by itself 5 times, we call that a to the power of 5. Once we do that, we get into three rules that we need to multiply exponents, and we need to divide exponents, and we need to raise one to the power of the other. Before we go any further, I need to introduce this idea to you. So let us say I have a exponent that looks like that. That is called the power, and that is called the base, and the whole thing is called exponent. So the first rule that you need to know is product rule. Now the word product means multiplication. So if I am multiplying an exponent by another exponent, very important to observe. Notice here, these two, they have the same base. Now, all these rules that we're talking about, they work only if they have the same base. Now, if they have the same base, then I simply add the two numbers that are the powers. Example, if I have a to the power of 3, and if I'm multiplying that by a to the power of 5, then I go a to the power of 3 plus 5, and I get a to the power of 8. So when we are multiplying two exponents, we add the two powers. This works if the exponents are positive, negative, or it works even if it is 0. Now let's see why this is true. So a to the power of 3 is a times a times a to the power of 5 is a times a times a times a times a. Now count all of them. We have 3 in the first bracket. We have 5 in the second bracket. So 3 and 5 together will give us 8 A's, and that is why it's like that. All right. So we have a rule for multiplying exponents, and obviously you must be wondering, oh, we must have a rule for dividing as well. So what if we have a rule that's for dividing? We call that the quotient rule. The word quotient means to divide. The quotient rule goes like this. If I have a to the power of m and a to the power of n, if I'm dividing, then I subtract the two powers. Now, in the case of the product rule, we added the two powers, m plus n. In the case of the quotient rule, we subtract the two powers. Now, how does this work? A to the power of 5 divide by a to the power of 3. The example here, this will give us a to the power of 5, take away 3, that would be a to the power of 2. Why is this true? So a to the power of 5 is if you multiply a by itself 5 times. A to the power of 3 is if you multiply a by itself 3 times. The a's in the numerator, there are 3 of them, they cancel the 3 a's in the denominator out. It leaves us the 2 a's, which is a squared. Okay, now what if we have to do a power of a power, something like this, a to the power of m to the power of n, that would be a to the power of m times n. Example, so a to the power of uh, 3 to the power of 2. Notice the whole thing is raised to the power of 2. So this would be a to the power of 3 times 2. That would be a to the power of 6. Now, why is this true? So, so because we have this power, so I'm going to erase that and I'm going to use the red to indicate that. So what we have now is we have a cube and a cube. Now, why did we do that? Because this power is 2. That means a to the power of 3 must be happening twice, multiplying itself. So here, this is the same thing as a to the power of 3 plus 3, which is a to the power of 6. And that's the reason why this works. Now, there are some special ones that you need to know. And the first one is a to the power of 0. Okay, so a to the power of 0, how do you calculate a to the power of 0? The right answer is actually a to the power of 0 is 1. But why is this true? So there are two ways you can approach this and then get this right. So whenever we divide a power m by a power m, so what we're doing here is we're dividing something by itself, something like 3 divided by 3, 5 divided by 5. If you divide something by itself, it is always 1. At the same time, if you have a power m over a power m, if I use the quotient rule, I have to subtract a power m minus m. That would be a power 0. And so now, because if we go one way, we get answer 1. We go the other way, we get the answer a power 0, which means that a power 0 must equal 1. So these two must be equal. And that's how you get this. All right, see you guys in the next video.